draw a contour map of the function showing at least 3 level curves. Contour map, level curves, kind of synonyms there. Well, okay, so we're going to do part B. So remember, when we talk about level curves of a 2-input variable function, we're talking about setting the third variable, the output variable, z, or in this case f of x, y, equal to a constant. And then graphing the result in just the regular old xy plane, right? So what would be a pretty convenient c value, a constant value, to set f of xy equal to in part B? Yeah. How about even easier? How about 0? So let's start with c equals 0. And then you get 0 is equal to y plus the natural log of x. Or if you solve that for y, what do you get? In fact, it might be quicker up here to think of it as c equals y plus the natural log of x, and solve it for y and get y equals natural log, well, it'd be minus natural log, right, of x plus c. That might be, since you're going to have to do it for 3 level curves, you might want to just do it up there, right? And then when c equals 0, we get y equals the opposite of the natural log of x. Does that make sense? Okay, so I need an xy plane here, so let me put it over here. And then here's x, here's y. Well, I know what just the natural log of x looks like. So don't draw this. This isn't the answer. The natural log of x looks like this, doesn't it? Goes through, I know it goes through 1, 0, right? So what does the opposite of that look like? So something like that, right? You reflect it across the x-axis. The y-axis is an asymptote. You buy that? So you guys can put in more detail. You guys can plot extra points if you want, but I'm going to just put in that amount of information. So it does go through 1, 0. I'm at least going to put in that piece of information, right? And this would be the level curve or contour curve or contour that you would get if c equals 0. You buy that? So maybe, you know, I could improve on it a little bit. It might look more like that, right? But again, it's just a sketch. I'm not trying to do a totally accurate piece of work here as far as individual points. What would be another good value for c? Sure. So if you plug in c equals 1, you end up getting just y equals negative natural log of x plus 1, don't you? And what would adding 1 to the natural log function, well, the opposite of the natural log function, so we could kind of use this as a parent graph. What would adding 1 to that graph look like, to the function that generates that graph? It would just move the entire graph up 1, wouldn't it? Called a vertical translation or a vertical shift. So instead of going through 1, 0, what would it go through? Yeah, I guess it'd be 1, 1 up here, right? So, and again, I'm not going to try and get too awful accurate. Something like that. C equals 1. And I think you've got the idea. C equals 2. If you let C equals 2, it's going to be, I don't know, up here somewhere, right? C equals 2. Again, that's just a quick sketch, not very accurate. But it's accurate in how the contour curves are related to one another, isn't it? So that wasn't so bad, right? Yeah, it's not bad at all.